Good morning, year fives, and welcome to your maths lesson. I hope that you've had a really wonderful half term and that you managed to do something fun and exciting. I know under the circumstances it's not really all that enjoyable, but I do hope that you managed to have a bit of a rest and you did manage to have a bit of fun. This week, we're going to be looking at fractions again, and we're going to be exploring fractions and doing a little bit more with our fraction knowledge. But in order to make sure that we're understanding our fractions, we need to revisit some of the concepts that we taught last term. So today's lesson is just going to be revising those fraction concepts and those methods. So hopefully you're going to whiz through today so that the coming days that we've been looking into fractions is going to be really simple. So today's lesson, learning objective is just going to be to revise those fractions and those methods that we've been looking at and to make sure that we understand the vocabulary that we have introduced to you from last term. So your starter for today is just going to be matching up the fraction knowledge that we have been teaching you with the vocabulary. So can you now pause the video and then match up those three very quickly for me? Super, so let's have a quick go at this. So we have a whole number and a fraction. So if we have a whole number plus a fraction, it is going to be a mixed number. If our bottom number, which is our denominator, is smaller than our top number, which is our numerator, it is going to be an improper fraction. And when our numerator is smaller than our denominator, it is going to be a proper fraction. Now, it is very important that you understand those terms and that you are able to identify them, because when you are asked to convert or to write your answer in a certain particular way, it is very important that when that you're understanding that the terms. So we're going to be looking at our big question now. So we're going to be looking at who has more pizza. Is it Miss Fink, myself, or is it Miss Morvena? And you need to have a look at these two fractions that I've given you. Can you remember what this kind of a fraction is called? Well done. It is a mixed number because why? Super. It's got a whole number and a fraction. And what kind of a fraction do we call this? Great job. It is an improper fraction because, great stuff, guys, our top number is bigger than our bottom number. Now, in order to compare these, I cannot do it just by looking at them. I need to be able to compare them with the same. So what's standing out to me that's really helpful is that both my bottom numbers, my denominators, are the same, okay? However, I can't be able to compare them because I've got a mixed number and then I have an improper fraction. So we need to change one of them. So I would like you to pause the video now and have a go at having a think about how you can compare these. And if that word comparison is coming to your mind, we did it last term, what can we do to compare these? So just have a go at having a think about this. I know that some of us might be a little bit rusty from last term because we've had a whole week off, but see if you can just have a go at trying to figure this big question out. Okay, let's go through it together. So first of all, I've got a mixed number and I have an improper fraction. So I'm going to make them both improper fractions and then I can compare them easily. Now, I'm already happy because my bottom numbers are already the same. So once I change this mixed number to an improper fraction, they're going to be both with the same denominator and then I can easily compare the top numbers. So I'm going to convert this mixed number into an improper fraction. And the method is, and hopefully you have remembered it, is what must I do with these two numbers? Great job, is that I need to multiply them. And then what do I need to do with the top number? Great job, I need to add them. So I say 3 times 3 is 9, 9 plus 1 is 10, and I have thirds. All right, now I've got an improper fraction. I have an improper fraction. Both my denominators are the same. And now I simply look at the top numbers and I say, right, which one is more? Is 10 or 22? Which one would you say is more? Great job. It is 22 thirds is going to be bigger. And therefore, Miss Morvena has more pizza than I do. And hopefully that's starting to jog a few of your brains and remembering how we converted our mixed number into an improper fraction. Okay, so we're going to now look at some of the vocabulary. Now, this is very important that we're understanding these terms because like I said earlier, we're going to be looking at these terms and we're going to be using those terms in our maths vocabulary. And it's very important that if I say to you, look at the numerators or look at the denominators, you know what those words are, especially when I've been using it in your steps to success and I say, make sure the denominators are the same, that you're making sure the bottom numbers are the same and not the top numbers. So it's vital that you are making sure that you understand these terms. And also if you are having to convert your fractions, if you know what you're converting, is it an improper? What is an improper fraction? Or is it a mixed number? What's a mixed number? So it's very important that you're understanding these. So very quickly, if I had a half, my numerator is going to be my top number and my denominator is my bottom number. Now, I remember being at your age and having to learn these words, and they are big words, and sometimes I got confused between the numerator and the denominator. So I used to look at this D here, and I said, if I swap it around, it becomes a B, for B standing for bottom. So I remember the denominator was at the bottom. You might have another way of remembering the numerator and the denominator, but that might just be one of the helpful ways that will help you to remember the terms. So top number is our numerator. Denominator, if I switch the D around, it becomes a B for bottom number, and that's how I can remember those terms. Improper fraction, we had a look at in our starter, which is when our top number is bigger than our bottom number. A mixed number is when I have a whole number and a fraction, and a proper fraction is when my top number is smaller than my bottom number. So I'm going to try and stop using the top and bottom words. I'm going to start using numerator and denominator because those are the words that we use in maths, and that is what we need to start using in our fraction vocabulary. So we're going to go through some of the concepts that we learned about last term, and these are very important because, as I say, a lot of it forms the foundation of our understanding moving forward. Okay, so we're going to be looking at our mixed to improper. Now, we did this one earlier in our big question, so hopefully you have been reminded of how we convert these fractions. So if I have a mixed number, it means I have a whole plus a fraction, and so I'm going to then change it to an improper fraction by saying 5 times 1, and then which is 5, and then I add the top number, which is 2. So 5 plus 2 is 7, and I leave the bottom number the same, fifths. Keep it the same, and that is how I leave it. All right, and there I've changed my mixed number into an improper fraction. If I'm going from an improper to a mixed, I'm now going to say how many groups of 4 can I make with 17? Okay, so 17 goes is divided by 4 how many whole times, and I can make 4 whole groups. Now this is where some people get very confused, and so what I'm going to suggest to you is, if it's going to be easier for you, is to draw out 17 little dots or little lines. Okay, and if you carry on going, and then I'm not going to do them all now, but you can count 17 lines, and then you're making groups of 4. The bottom number always tells me how many times I'm going to group my little sticks into. So I'm going to count 4, 1, 2, 3, 4, and I'm going to put a circle around it, and I'm going to keep going, and that will give me the whole number. Okay, so you've got to write the whole number quite big, and then what am I left with? So 4 goes into 17 4 times, which makes 16. So I've now taken 16 away. So I'm left with 1, and I leave the bottom number the same, which is quarters. So I've got 4 and a quarter. All right. So I'm just going to go through that step one more time. So if it's going to help you, draw out this number here. So if it's 17, if it's 20, if it's 30, draw out little sticks. Circle the groups that you're making. So the bottom number here, the denominator, is going to tell me how many I'm going to count. So I'm going to count groups of 4, put a circle. Count a group of 4, put a circle. However many circles I have is going to be the whole number. Whatever I'm left with is going to be my numerator for my fraction. And then my bottom number, my denominator, is going to stay the same as whatever this denominator is. And the last one is my equivalent fractions. So when I'm making an equivalent fraction, I'm going to be drawing my arrows to the missing information, which is over here. So I point my arrows, and then I look at the denominators because there's more information here. And I say, what I do to 4 to get 16, I times it by 4. And now it is very important that you stop and you pause and you go, is 4 times 4 16? Because quite often what we do is we tend to put the wrong symbol here. And so it's very important that I make sure that I'm stopping and I'm pausing and I'm checking, because if I do this incorrect, then my answer is going to be incorrect. Many of you will sometimes put divide by 4. And then if you went and checked that and you said 4 divided by 4, is 4 divided by 4 going to give me 16? No, it is not. So that's why we draw the arrows And that's why we put it in and we pause, we check. And if we're happy, is 4 times 4 16? I'm going in that direction. Yes, it is. Then I'm going to do the same to the top number, which is my numerator. And I say 3 times 4 is 12. And I have 12 16ths. Now, a reminder that equivalent fractions are still taking up the same amount of space. It's not in a different number. It's still the same amount, okay? Right, now we use our equivalent fraction knowledge to make our addition and subtraction sums to be able to answer them. So very important is step number 1, are my denominators the same? Now you would hopefully remember that my denominator is my bottom number. So if I look here at my denominators, they are not the same. So in order for me to add them, they need to be the same. If they are the same already, oh, that's amazing, that's wonderful. Then all I have to do is add or subtract the top numbers depending on what operation I'm doing. But here, I do not have the same denominators, so I need to make sure I change them. So first of all, I'm going to look at the biggest denominator, which is 12. Now I look at the smallest one and I say, can this number go into that number equally? Can 3 go into 12 equally? So 3, 6, 9, 12. Yes, it can. So my denominator is going to be 12s. Now I need to make an equivalent fraction because I have changed this 3 and I have made it into 12ths. So what have I done to the 3 to get 12? I have multiplied it by 4. So whatever I do to the one number, I need to do to the other number. So I need to now multiply the 2 by 4, which is going to be 8. Bring down the plus sign so that I know that I'm adding and not subtracting. And then what did I do for 12 to get 12? I did nothing, so I leave the top number the same as well. Now that my bottom numbers are the same, I can easily add my top numbers. Do I ever add the bottom numbers and denominators? Great, I never add them, I leave them the same. So first of all, I'm going to leave it as 12ths. I say 4 plus 8 is also 12. And now, when I'm really thinking in higher grade maths, I'm trying to really think about my fractions here. If I have a pizza and I've divided into 12ths because my bottom number always tells me how many slices I've divided into or how many groups I've divided into. So imagine the pizza, imagine that you cut it into 12 slices and I've eaten 12. How many pizzas have I eaten now? If I've cut it into 12s and I've eaten all 12 pizzas, how many pizzas did I eat? I ate 1 whole. So whenever my top number is the same as my bottom number, it means it's worth 1. Okay, so that's very important. So 12 12s, yes, but if I said to you, how many pizzas did you eat? You're not going to say to me, oh, Miss Fink, I ate 12 12s of a pizza. You're going to say, Miss Fink, I ate a whole pizza. I ate 1 pizza. Okay, so you do need to start thinking about this with your maths. Right, so that's when I add. If I was doing for subtraction, I would do exactly the same, except that I would then subtract my top numbers. And I can't do it with this one because it won't work out. But if I was subtracting, I would just look at my numerators and I'd say this number, subtract this number would give me my answer. And then I would leave the bottom number, the denominator, the same. Very important. Right, so I would like you to pause the video now. There are a couple of questions and I will then scroll down for you just to have a quick go at before you go onto Teams and do your revision of last term's concepts. So just have a go at seeing if you can remember those methods, remember those steps to success that we did last term. And if you do get stuck, I will make sure those steps to success are all saved in the maths folder for you for your team's task so that you can go through those steps to help you. Or you can rewatch the video and go through those, the concepts that I've just revised. So here are your questions. So at any time, please pause the video and then you can do them. So your first one is going from an improper fraction to a mixed number. So I have 24 fifths. So how can I make that into a mixed number? Yeah. Then I have equivalent fractions. I have 2 9s. How many 27ths am I going to make? Right, I'm going to subtract these numbers now. Okay, so can you please subtract these 2 fractions? And the last one is mixed to improper. Can you please make an improper fraction with this mixed number? Okay, so if you at any time need to pause that, make sure you've paused it and how to go at it because this is going to help you. So let's see how well you did. Right, So I'm going from an improper fraction to a mixed number. So I'm going to say 5 goes into 24 4 whole times, okay, because I don't have enough to make 5 whole groups. I've got 24 sticks. So if you needed to draw your little sticks out, do that, and then group them into groups of 5, and you would have 4 groups of 5. What are you left over? You'd be left over with 4, and we leave the bottom number the same. So I have 4 and 4/5. Equivalent fractions, again, making my little arrows. Okay, remember I always point to the missing information. I go, what did I do to 9 to get 27? I multiplied it by 3. So I'm going to do whatever I do to the one number, I need to do to the other number. And before I even carry on, I'm going to stop and I'm going to check. Is 9 times 3 27? Yes, it is. So now I'm happy to do 2 times 3 is 6. And so my answer is 6/27. Right, adding and subtracting fractions. I'm subtracting the 2 fractions here. So I'm going to be looking at the bottom numbers, my denominators. Are my denominators the same? No, they are not. Therefore, I cannot subtract these numbers. I cannot say 9 minus 2. Okay, because these bottom numbers, my denominators need to be the same. That's very important. So I look at the biggest number, which is 30, and I say, can 15 go into 30? And hopefully you know it can. Right, so I'm going to have 30. Now, what did I do to 30 to get 30? I did nothing. So I'm just going to leave the top number the same. Okay, I'm going to leave it the same, 2. I'm not going to change it because I haven't changed the 30 at the bottom. Now, what did I do to 15 to get 30? I multiplied it by 2. So I'm going to say 9 multiplied by 2 is going to be 18. So I have 18 30ths and 2 30ths. And now I'm going to bring down my subtraction sign because quite often this is where silly mistakes come in and children add these numerators instead of subtracting them. Now that I'm going to be subtracting them, I'm going to say 18 minus 2 is 16. And I leave the bottom number the same, which is 30. Okay, so I have 16 30ths. Now, I know some of you have figured out that you can then simplify the fractions. You can then, and I'm not going to explain that too much because what I'm going to do is discourage you from doing that, because often in an arithmetic paper or a reasoning paper, if you decide, if you write the fraction and then you simplify it or you change it back into a mixed number, and you do it incorrectly, you will get marked wrong. Whereas if you had just left it as an improper fraction, or for example, this fraction here, as it is, you would then get the mark. So please do not simplify or change it back into a mixed number if it's from an improper fraction. Just leave it like this. And if you have a little bit, if you are thinking, Ms. Fink, what are you talking about? Please don't panic. Just do exactly what we've done here. Leave it at this step. Some children have started to realize that I can make the fraction simplified, which means that I can make an equivalent fraction, but much smaller. I would like you just to leave it as this, because as I say, this will be accepted. And some children who then go and simplify it or change it and they do it incorrectly, they then will not get the mark. And I remember this very clearly from my first year of being in year 6 when I was teaching year 6s. And I had a child who wrote an arithmetic paper and he got 1 wrong because he wrote the correct fraction, but then he simplified it and he simplified it incorrectly. And because he wrote that as his answer, I can't give him that mark, okay? But if he had left it as it is, and he left it like we've done in this step here, he got this answer, but then he went and changed it to simplify it, and then he didn't get that answer. But if he had just left it like this, he would have got the answer, okay? He would have got that mark. So he missed out on full marks because he did that. Now, please don't do that. And so I just want to discourage that. Our last one that we're going to be looking at is our mixed to improper. This is our nice little easy method, making sure that we know our tables. Remember, those children who are struggling with their tables, it's important that you're logging on to some sort of hit the button or your Pixel times tables or your TT Rockstars, whatever you have, that you can then be practicing your tables, okay? It's so vital for your maths. Right, 7 times 5 is 35, and 35 plus 3 is going to be 38. And I leave the bottom number the same, which is 7. Okay, and that is my improper fraction where my top number is bigger than my bottom. My numerator is bigger than my denominator. Hopefully that's jogged your memory from those concepts. If it hasn't, please go back in the video, re-watch those steps to help you. I will also put the steps of success in Teams for you, so it's all there. And then make sure that you're really, really understanding those, because those are going to help you. Okay, so there's one last thing before we go on to our teams, and this is a word sum. Now, word sums are just basically taking what you've learned and putting words in between, and there's nothing tricky about it. The only thing that you need to do is read your questions very, very carefully. Okay, so it says, Mr. Prendergast ate 1 3/12 of a pie, and Mr. Bruce ate 14/12 of a pie. So I would start by writing these two fractions down. I have a mixed fraction number, and I have an improper fraction. Right. Who ate the most pie? Now, here is a prime example of, we've done this in our big question, but I just gave you the two fractions. Here, I haven't given it to you so clearly. I've given it to you in a word sum format. So you have to now read the question carefully, and I'm asking for who ate the most pie. So I'm wanting a person's name. So you're going to do your working out, and then you've got to answer the question based on your working out. And that's why word sums tend to trick you out, because a lot of you, I'm going to assume, are going to just write the fraction, and the fraction is not correct. I want to know who, and when we refer to who, we're looking for a person. So first of all, I have two fractions that are different, and I need to make them the same. So I'm going to change this into an improper fraction. So I'm going to use my methods that I've understood, which is times and plus, and I'm going to say 12 times 1 is 12, and 12 plus 3 is 15/12, and I have 14/12. And now I can look at the bottom numbers are the same, and if the denominators are the same, I'm feeling very happy, because if they're the same, I can simply compare the top numbers, and I say, right, 15/12 is bigger. Who had 15/12? It was the mixed number, and the mixed number belonged to Mr. Prendergast. Therefore, my answer that I would write would be Mr. Prendergast. I'm going to put one like this in your test today. So please make sure that you've understood this so that you can really get all the marks today. Okay, so I'm going to be asking a who, and I'm going to see who, who has been concentrating in this lesson so that they can make sure they get the answer. Right. So at any point, if you're struggling, remember to rewind the video, do it again with me, do it on your piece of paper. Don't try and do it in your head. Even I have to do them on a piece of paper when I'm working out the answers. Okay, so try and do it with me. And then if you get stuck, go back, rewind, and go through it again. So log on to Teams now. You're going to have 10 questions based on these methods, converting them, comparing them, and then some word sums, and see how you do with those questions. So good luck, enjoy, and I hope you have a fantastic day of learning, and I will see you back here later. Bye, guys.